So welcome back. We're now going to talk about expressions. Expressions are a little more complex calculations that we can sort of do on the right-hand side of an assignment statement. So one of the things about expressions is operators. And the operators in computer programming are often very much the same as the mathematical operators, but we don't have all the fancy characters that we have in mathematics, and so we have to choose what's on the keyboard. And then we really go back to the 1960s and 1970s, and we used what was on the keyboard in the 1960s and the 1970s to make these operators. So plus is addition, minus is subtraction. We don't have a times sign or a dot in the middle, so we use the asterisk as multiplication. Division, we can't put two things over top of each other, so we use slash for division. Raising to the power, because it didn't have little characters back then, is star star, which is raising to the power. And then remainder. Remainder is when you do integer division, it's also called the modulo operator, it's the remainder, not the quotient. And I've got a picture of that coming up. So here's a whole series of little examples of this. Right? So we've already seen, the plus, x equals x plus 1. Keep remembering that these assignments are arrows, basically. Arrow, arrow, they have a direction. Multiplication, 440 times 12. Dividing this by, that's division, over 1,000, 5.28. Here we're going to put 23 into JJ, and then we're going to do modulo. So that says, take 23, divide it by 5, and give me back the remainder and put it in KK. So this is the expression that evaluates like this. Take 23, divide 5 into 23, 4, remainder 3. The 3 is what comes back up here. Okay, and so that is the remainder. It's also called modulo operator. It turns out that for things like picking a random number and then taking the modulo of 52 is a way to pick a card randomly. So this modulo operator is actually, especially in games and other things, super useful. So that's the various operators. It's important to know which of these operators goes first. That's called operator precedence. Now normally we put parentheses in, like, so if I put the parentheses in here, I'd say this goes first, parenthesis, then this goes first. Oh, actually not that one. Oops, got that one wrong. This happens first, this happens, then this happens. Okay, and so, but it's important for us to be able to know, if there were no parentheses, the order in which these things will happen. So the way things work in terms of operator precedence is parentheses are the most important thing, followed by raising to the power, all else being equal. Multiplication and division are all both equal, and then addition, and then within it's adding left to right. So let's see an example of how this works. And so if we take 1 plus 2 to raise to the 3 power divided by 4 times 5. And we print out what comes out of this. So the way I did this when I was taking exams back many, many years ago when I was first in computer science is I'd write it all down and I'd look for the highest precedence thing. Now parentheses would make this easy, but exponentiation is the first one. So that means we're going to take this, and that's going to be 8. 2 to the 3rd power, 2 times 2 times 2, 2 cubed is 8. Then what I would do is I rewrite the whole thing with the 8 there. And now I look across and I'm looking for multiplications because the power's been done. The multiplication is what I'm looking for next. And then there is both multiplication and division. They're equal. They're at the same level. And so what happens is they're done left to right. 8 divided by 4 happens before 4 times 5. And so the fact that it's not 4 times 5 but instead 8 times 4 is because of the left to right rule. So then this gets rewritten to be 2, 1 plus 2 times 5, and this one, multiplication, is the top one, so that does this next. 2 times 5 becomes 10, I rewrite it again, and then 1 plus 10, addition is the lowest thing, and that's how we end up with 11. And so that's how I would do these problems if I ever saw the problem on an exam. And it's a fun problem to put on exams because there is one and only one answer, and every programming class has usually at least one slide about this stuff. So like I said, the rules go top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about variables and computing values to put inside variables, but the one thing you've kind of also, maybe you noticed it as we go by, is we have different kinds of data. We call it type. Is this of type integer? Is this of type floating point number? Is it of type string? What is going on here? And Python is pretty smart about various kinds of types of data. And so, we're adding 1 plus 4 here, and Python knows as it looks at this that that's an integer and that's an integer, and we'll add it together and make it an integer. So that thing is an integer. We can also use this plus to concatenate two strings. This is hello blank plus there. And plus looks here, says, oh, that's a string and that's a string. So I know what to do with strings. I will concatenate those two things together so it becomes another string that gets assigned into E, and it's hello space there. The plus doesn't add the space. I added the space by putting it right there. And so these operators are kind of smart in that they kind of know what they're dealing with, and sometimes they will do one thing or another depending on the kinds of values, variables, or constants that they're working with. And so sometimes type can get us in trouble. So here we have EEE, which is hello there because we've concatenated these two strings together. And now we're adding 1. And the problem now is that it looks on one side and says that's a string and that's a number and says I don't know how to do that. This is another one of those annoying errors that you think that somehow Python doesn't like you, but it just is confused. If you look at these things, traceback always means I quit. It means I stopped, I ran, I'm quitting now because I don't want to go any farther because I've become confused. So your program stops running and you say, here's where I stopped running. Because we're typing interactively, it's always line 1 here. Type it, but if you read carefully and you don't get too stuck on too much stuff, line 1 that tells us something in module type error, can't convert int object to str implicitly. So that's an integer right there, and that's a string, and that's what it's complaining about, that little bit right there. If Python is so grumpy about types, then we should be able to ask it about types. So there turns out that there is, inside Python, a built-in function called type, T-Y-P-E. So we can pass into type. So the syntax is calling a built-in function named type, parenthesis is the parameter that we're passing to it. We're saying, hey, hello, tell me something about the type of the variable EEEE. And so this is a function, the parentheses are part of the function call, and it says, oh, that would be of class string. And then we can pass in a constant and says, hey, what about hello? The string hello, it's like, oh, that's a string too. What about a 1? Well, that's an integer. And so we are asking Python through the type function what the type of either a variable or a constant is. And there are even several types of numbers, and we'll even see Booleans and others later. Like 1 with no decimal, that's an integer number. 98.6 with a decimal, that's a floating point number. And so, constants can be both integer and floating point. And I'm just asking over and over and over again, what is the type of what's in XXX, what's the type of what's in temp, and what's the type of the constant 1. And what's the type of 1.0. You can also use a set of built-in functions like float and int to convert from one to another. And so this basically says, I want to convert, let's go back. I want to convert 99 to a floating point number. So this is a function and it's participating in this plus, but before it can finish the plus, it turns this into a 99.0. The difference between 99 as an integer and 99.0 is that it's a floating point number, and that actually turns this computation, as it looks to the left and looks to the right, says, oh, I've got a floating point number on one side and integer on the other side, and so I'm going to make my calculation overall be a floating point calculation. I can also pass into the float function. I can say, take this variable I, which has a 42, also an integer, and then give me back a floating point. So that'll be 42.0. Pass that into F, we print it out, and it is indeed 42.0, and it's a float. And so it knows the type and value in any variable. This is an integer, a value 42. This is a float, a value 42.0. Integer division in Python 2 was kind of weird, and it was actually one of the big things that they changed between Python 2 and Python 3. This is a Python 3 course, so we're not worried about that too much. What's nice about integer division in Python 3 is it always produces a floating point result. And that means that Python 3's division is more predictable and it works more like a calculator. So in this case, I mean, you can go back and look at my Python 2 lectures and see how crazy it was in Python 2. 10 divided by 2 is 5.0. And the weird thing here is these are both integers, but the division forces the result of the calculation to be a floating point number. And this, 10 over 2 could be 5. But 9 over 2 is 4.5. And so that is accurate. In old Python 2, that would give us back 4, which is completely unpredictable and weird. The same with 99 over 100. As you would expect, if this were a calculator, you get 0.99. Actually, what you get in Python 2 is 0, because it would round it down. It doesn't round at all, it truncates it. So 99 over 100 is 0.99, and then it truncates it to 0. That's Python 2. We're not talking about Python 2. There's a good reason we're not talking about Python 2. Welcome to Python 3. Of course, if there are a floating point on either side, the result is still a floating point, and the result is still a floating point. So integer division produces a floating result in Python 3.0, not in Python 2.0. That is an improvement in Python 3.0. And that's why we're recording these lectures. I have a whole great set of lectures about Python 2, and now I'm going to have a great set of lectures about Python 3. Welcome to Python 3. Okay, so we've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer. It is a 3-character string that has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says can't convert into string, so that blows up, right? Because this is a string. It looks to both sides. String plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into an integer. So take the input of sval, which is the string 1, 2, 3, and give me back an integer representation of that, which is going to be 123. So we say, what kind of thing do we get back? Well, we got back an integer. We can now add 1 to it and get 124. And so you have to manage the type of things, and you can convert from one type to another. Now, int is not magic. If you send something into it, a string that doesn't consist of digits, then you're going to end up with another error. Invalid literal for integer with base 10, blah, 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 blah. So it's really complaining. It says, I want these to be numbers here, and you just gave me letters, so that's going to cause this to fail. Another thing that we're going to do with variables is, just like the print function takes something, a list of things, in this case, a string, comma, a variable, and then prints some output in the program, the opposite of that is input. Actually, input generally happens before output. Input is a built-in function, and we pass to it a prompt, a string of text that's going to be printed out for the user, and then it stops and waits. So it says, who are you? And then right here it just sits, waiting for us to type something. So we type blah, 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 and then hit the enter key. Right? We hit the enter key, and then this text ends up in this variable. So this is an assignment statement that Chuck is the result of the input call, gets copied into the NAM variable. So let's do that again. It's evaluating an assignment statement. Remember, it's kind of this way, or you can think of it as just do this right side first. It writes this out, writes that out, then it waits, wait, until we hit the enter, and takes this Chuck, and that becomes the result of this input, which is then assigned into NAM. Now then we go sequentially to the next line. It prints out welcome, comma, contents of the variable NAM. Now this comma here, actually does put the space in here automatically, so it says welcome space Chuck. So it pulls there's no space in Chuck, just the CHUCK. And so print can take more than one thing separated by commas. As a matter of fact, print can have, a whole bunch. Oops, come back. Print can have comma, 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 parentheses, as many as you like. Everything you've seen up to now is kind of one thing in the print, but that doesn't mean that print only can do one thing. So I've talked about variables, we talked about constants, we've talked about input, we've talked about output, and now it is time to write our first meaningful program. And so this program has to do with those of you who have traveled internationally. If you traveled to the United States and you traveled outside the United States, you notice that there is an elevator convention that is different inside the United States. In the United States, walk in the ground floor in the elevator, that's 1. And if you walk in the ground floor in Europe or many other places in the world, and the elevator is 0. So we have written a small app that we're going to put on the App Store and get wealthy with called elevator floor conversion app. And it's going to ask us, we're in Europe and we're lost, and you say, well, what floor would this be if I was in the United States of America? And so we have to read the floor that we are in Europe, and then we're going to convert it to a US floor, and then we're going to print it out. This is very silly, but it is a pure essential program that has input, does some kind of task on that input, and then produces some output, which is useful for some value of useful. Okay? So let's take a look at how we combine everything that we've learned in this lecture: input, processing, and output. It's a 3-line program, but it's sort of the beginning of something that programs do. Okay, you're going to do lots of programs that do this. So here we go. Program starts. We do the input side effect. It prints out this and then waits. We type in 0. That comes back here. And the 0, which is a string. Input gives you back a string. It doesn't give you back a number. It was a little different in Python 2, but in Python 3, input gives you a string. So quote 0 quote, which is what we typed here. We didn't type the quotes, it's a string, gets stored in the imp variable. Then we move to the next statement, and on this right-hand side, we convert that string variable to an integer, so that becomes the integer 0. We add 1 to it, and then that becomes 1, and then we assign that into USF. I've named this variable United States floor, right? So imp is the input and USF, that's mnemonic. It doesn't know anything about elevators, it's just I picked a variable that was quite friendly. And so at this point, USF has the United States floor that's equivalent to the European floor, and then I just fall down and I do a print statement. Print out US floor, comma, that's this space right here, and then whatever the contents of the US floor variable is. And you could see that I could write this on 4, and it would say 3. I could write this and say 7, and it would say 6. This is an amazing program. It converts floors in a European numbering scheme. Wait, actually no, I got that wrong. Hang on, let me clear this. I wasn't thinking clearly. I could type in 4 and it would give me back 5. I could type in 6 and it would give me back 7. See, I'm confused. Haven't been in Europe in a couple of months, and so I forgot all about the floors. But that's the idea. Now, this is a super simple program, not super useful, but you get the idea that we're going to pull some data in, we're going to do some intelligent thing. Soon this will be hundreds of lines of code instead of 1 line of code, and then we're going to present the results to our user. Now, another element of most any programming language is what's called a comment. A comment is a way for you to put in a program file some text that's to be ignored by Python or C or whatever language we happen to be using. In Python, comments start with a pound sign. So what you could do is put a pound sign anywhere in a line, and then after the pound sign, Python ignores everything after that pound sign. It can be the first character. So here's our recurring concept that we talk a lot about. We're not going to cover this. Remember what this does. This is counting how many letters. There's 16 thes, and there's in that file there was 6 2s or whatever it was. This is that code. We'll get back to this code. But what we've done here is I've added some comments that are really for human consumption. So this first paragraph is get the name of the file and open it. The second paragraph is count the word frequency. You know, maybe I should have said histogram here. Count the word frequency and assemble a histogram. And then here I'm putting this pound sign in, find the most common word, and then I'm all done. I print the stuff out, right? And so all I'm saying is comments are for people to read. Your next programmer or the person who's going to change your program after you're done with it. And they're nice, and you don't have to use any particularly weird syntax or variable naming conventions. You put a pound sign in, and you can write anything you want from that point forward. Okay, so we've talked a little bit about variables and types and mnemonics and how we would choose variable names and how expressions work and the various operators, converting between different types, printing, input, output, and comments. So that just kind of gets us sentences. And coming up next, we'll talk about conditional execution, where we're really starting to move up to paragraphs. So see you in a bit.